You are welcome to today's lesson. We are continuing our discussion on rigid motion. And our focus for our discussion is reflection in the line x equals k. Now, what are some of the types of reflection we've looked at so far? We've looked at reflection in the x-axis. We've also looked at reflection in the y-axis. Reflection in the line y equals x. We've also looked at reflection in the line y equals negative x. And today we are continuing our discussion by looking at reflection in the line x equals k, which can also be written as x minus k equals 0. Now, how do we perform reflection in the line x equals k? How will I be able to identify the mirror line? And so as usual, I'll need the x and the y-axis with my positive and the negative side of the y-axis. And on the x-axis, I have the positive and the negative side as well. And so we are performing reflection in the line x equals k. Now the k we see over here is called a constant. A constant means it can be any value, whether a positive or a negative number. So for instance, the k, whatever value I pick for k, is the same value for x. So if I pick k to be 2, it means my x also becomes 2. So this means I am performing reflection in the line x equals 2, because now the constant is known to be a value 2. So how do I plot this on the graph? Reflection in the line x equals 2 means that I just have to identify the point 2 on the x-axis, then draw a vertical line through it. So now this becomes the mirror line. Now, what if the value for my constant, or the k, is negative 3? What will become the x value? Automatically, the x value also becomes negative 3. And this implies that I am performing reflection in the line x equals negative 3. As usual, I just have to identify the point 3 on the x-axis. Then, in the same way, I'll draw a vertical line through it. So now this becomes my mirror line. So now let's solve an example under reflection in the line x equals k. So I have my graph presented already. And so this time around, we are reflecting the points 4, negative 2, and also negative 2, 4 on the line x equals 2. So the 2 over here, remember, represents the constant. And so what do? In the first place, we have to identify the point 2 on the x-axis. So on the point 2, we draw a vertical line that will pass through the point 2, which is on the x-axis. And so this line becomes my mirror line. So now let's move straight to our first point given to us, which is 4, negative 2. So we plot 4 on the x-axis, then negative 2 on the y-axis. And so as we always do, we are going to move this point towards the mirror line. This time around, I'm moving according to the scale I have on my graph. And so how many points am I going to move? So let's move. So 1, 2. So I moved 2 points according to my scale to get to the mirror line. In the same way, I'm going to move 2 points away from the mirror line to get the image point. So let's move 1, 2. So according to my scale, my last point over here is what we call 0, negative 2. So 0, negative 2 becomes the image point. Now let's come to the second point, which is negative 2 and positive 4. So in the same way, we are going to move this point towards the mirror line. So in the same way, I'm moving according to the scale I have on my graph sheet. So how many points am I going to move? So let's move and see. So 1, 2, 3, 4. So I moved 4 steps to get to the mirror line. In the same way, I'm going to move 4 steps away to produce the image point. So let's move 1, 2, 3, 4. So the last point over here forms a new point, which is 6, 4. So it means that the new image point I'm having right now is 6, 4. Now what do you observe? You see that the first object point was 4, negative 2, and that produced the image point 0, negative 2. The second object point was negative 2, 4, and it produced the image 6, 4. And so when we pick the x-coordinate of the first object point, it was positive 4, and it changed from positive 4 to 0. And one amazing thing is that the y-coordinate of the first object point is the same as the y-coordinate of the image point. Now when we come to the second point, which is negative 2, that is the x-coordinate of the second point, it changed from negative 2 to positive 6. And the y-coordinate of the object point, which was a positive 4, still remained the same as positive 4 in the image point. Now let's take note. Remember from our graph, the first point we plotted was 4, negative 2, and we're reflecting in the line x equals 2. And that produced the image point 0, negative 2. So the y-coordinate of the object point is still the same as the y-coordinate of the image point. So what we are saying is that anytime you are reflecting in the line x equals a constant k, always the y-coordinate of the object point will always be the same as the y-coordinate of the image point. It will never change. The only thing that changes is the x-coordinate. So the x-coordinate of the object point changed from positive 4 to 0. So how do we get the change? That is from 4 to 0 without using the graph. So that is what I would like to demonstrate. And so from here, I'll rewrite the object point in the column form. Then this is mapping to 2 multiplying another 2 minus 4. Then we can see the coordinate negative 2 downward. And this gives us the answer 0, negative 2. And remember, 0, negative 2 was the image point we got after performing our reflection. So what does this imply? Now there's the 2 we see in the bracket represent what we call the constant k. So that is the 2 we see here. So reflection in the line x equals 2, the 2 is a constant. So the 2, which is the k, is always multiplied by another 2. So always we multiply the constant k by 2 and subtract what we call the x-coordinate of the object point. So the x-coordinate of this object point was 4. So what did we do? First, I multiplied the constant k by the number 2 and subtracted the x-coordinate. So when we do that, 2 times 2 will give us 4. So 4 minus 4 is also 0. So that is why we have 0 as the x-coordinate of our image point. Now, when we come to the y-coordinate, just as we said, in reflection in the line x equals k, the y-coordinate remains unchanged. So that is why we see the y-coordinate repeating itself. And so, in general, when we have any object point, so let's say my object point is a, x, y, and I'm reflecting in the line x equals k, what this means is that I'm going to multiply the constant k by 2 and subtract the x-coordinate of the object point. Then we just rewrite the y-coordinate as we see. So the y-coordinate still remains the same. And when we do that, we'll be able to produce the image point A1. Example. We are to draw the triangle PQR with vertices P 6, 2, Q 5, 4, and R 3, 1. And secondly, we are to draw the image triangle P1, Q1, R1 of triangle PQR under a reflection in the line x equals 2. And lastly, we are to indicate the coordinates of the triangle P1, Q1, R1. And so as usual, I'll need a graph sheet with my x and y axis. Then I'm still using a scale of 2 centimeters to 1 unit. Remember, we're given certain points to plot. The first point P, which is 6, 2, Q, which is 5, 4, and the last point R, which is 3, 1. And we are reflecting in the line x equals 2. So in the same way, I'm going to identify the point 2 on the x-axis and draw a vertical line through it. So that becomes my mirror line. So quickly we'll pick the first point P and plot. So the first point P is 6, 2. The second point is Q, which is 5, 4. And the last point R, which is 3, 1. So quickly I'll join P to Q. I'll join Q to R. And the last point P to R. So that forms the triangle PQR. And so from the question, we have to reflect the triangle PQR on the line x equals 2. So quickly we'll pick the first point P and move towards the mirror line. Now remember, I am moving according to the scale of my graph. So let's move. So 1, 2, 3, 4. I move 4 steps to get to the mirror line. In the same way, I'll move 4 steps away to produce the image. So 1, 2, 3, 4. So the last point over here produces the image point P1, which is -2, +2. The same way, I'll pick the next point, which is Q, move towards the mirror line. So 1, 2, 3. So I move 3 steps. I'm going to count 3 steps away. So 1, 2, 3. So the last point over here produces the image point Q1, which is -1, 4. Then I'll come to the last point R and move towards the mirror line. Remember, we are moving according to the scale of the graph. So how many points will I move? So just 1. So in the same way, I'll just move a step to produce the image point, which is R1, 1, 1. So I'm quickly going to join the points together. So I'll quickly join P1 to Q1. Then I'll join Q1 to R1. Then lastly, I'll join P1 to R1. And that produces the image point P1, Q1, R1. Now what do you observe? You observe that the first point, which was point P, 6, 2, produced the image P1, -2, 2. Secondly, the Q also produced the image point Q1, which is -1, 4. Then the point R, which was 3, 1, also produced the image point R1, which is 1, 1. And so as usual, the x-coordinate of the object point changed from 6 to -2, whilst the y-coordinate remained the same. The same way, the x-coordinate of the second point changed from 5 to -1, whilst the y-coordinate remained the same. And the last one, the point R, the x-coordinate changed from +3 to +1, while the y-coordinate remained the same. Now let's take note that anytime I have a point xy and I'm reflecting in the line x equals 2, it means that I just have to multiply the constant k by 2 and subtract the x-coordinate and also maintain the y-coordinate in order to produce the image A1. And so the first point, if perhaps I don't want to use the mirror line and I just want to plot the image point straight ahead, all I need to do is to multiply my constant, which is 2, by another number 2 and also subtract the x-coordinate. So over here, the x-coordinate of the object is 6. So when we subtract, then over here, the y-coordinate still remains the same. So 4 will be the answer after multiplying 2 times 2. So 2 times 2, which is 4, minus 6 will give us -2. And the y-coordinate still remains the same. In the same way, with my point Q, 5, 4, I just have to multiply my constant k by 2. Then subtract the x-coordinate. Over here, the x-coordinate is 5. Then over here, the y-coordinate remains the same as 4. So when I do that and I perform the calculation, my Q1 becomes -1, 4. And the last point, which is point R, was given as 3, 1. And when I'm to perform the calculation, I'm still going to multiply my constant k by 2 and subtract the x coordinate. So now this time the x coordinate is 3. Then the y coordinate still remains the same. So after performing my calculation, I'm going to get R1 to be 1, 1. And these are the points we had for our image point. So P1 negative 2, 2, Q1 negative 1, 4, and R1 1, 1. Now your assignment for the lesson. You are to draw the triangle PQR with vertices P, which is 1, 2, Q 5, 4, and R 3, 8. Secondly, you are to draw the image triangle P1, Q1, R1 of triangle PQR under a reflection in the line x equals 6. Then finally, you are to indicate the coordinates of the triangle P1, Q1, R1. Thanks for watching and see you in the next lesson.